66 million years ago, Earth was not a quiet place. The continents were arranged differently. Sea levels were higher. The climate was warm, humid, and stable. Vast forests stretched across the land. Shallow seas covered much of what would one day become continents. Dominating nearly every ecosystem on land were the dinosaurs. They had ruled the planet for more than 160 million years, longer than humans have existed by an unimaginable margin. They came in countless forms, towering giants that shook the ground with each step, swift predators built for speed, herding animals that moved like living rivers across the plains. Life on Earth was complex, balanced, and thriving. No species knew that this balance was about to end. Far beyond Earth's atmosphere, something was already on its way. The object that would change everything began its journey long before Earth even existed. It was an asteroid, roughly 10 to 15 kilometers wide, formed during the early chaos of the solar system. For millions of years, it drifted through space, circling the sun in a quiet, predictable orbit. Then, slowly, that orbit changed. Gravitational interactions nudged it inward. Its path began to cross that of Earth. There was no warning, no sign in the sky that creatures on the surface could recognize as danger. On the morning of impact, Earth rotated beneath a clear sky. Dinosaurs fed, hunted, migrated, and nested as they had for countless generations. And high above the planet, the asteroid entered Earth's atmosphere at more than 20 kilometers per second. It was moving faster than any bullet, faster than any living thing had ever experienced. Within seconds, the air ahead of it compressed and heated to extreme temperatures. The sky ignited. The asteroid struck what is now the Yucatán Peninsula, near the present-day town of Chicxulub, Mexico. In less than a second, the energy released exceeded billions of nuclear weapons combined. The impact created a fireball hotter than the surface of the sun. Rock vaporized instantly. The ground behaved like liquid. The asteroid itself ceased to exist in the moment it touched Earth. A crater nearly 200 kilometers wide and 20 kilometers deep began to form. Shockwaves rippled through the crust at supersonic speeds. Anything within hundreds of kilometers was instantly destroyed. Not burned, not crushed, but erased. Forests vanished. Oceans were displaced. Entire ecosystems ended in the blink of an eye. Temperatures spiked dramatically, igniting forests on nearly every continent. Plants dried and burned. Animals caught in the open had no escape. Even far from the impact site, the heat was deadly. This phase alone may have killed a large portion of life on land. Yet the worst was still to come. As fires raged, a far more dangerous process was unfolding above. The impact had thrown enormous quantities of dust, soot, and sulfur-rich rock into the upper atmosphere. These particles spread around the planet within days. Sunlight dimmed, then faded, then disappeared, but the impact was only the beginning. The force of the collision triggered earthquakes far stronger than any recorded in human history. The ground shook across entire continents. Fault lines shifted. Volcanoes already active around the world were jolted into renewed eruptions. In the oceans, the seafloor buckled violently. Water surged outward in colossal waves. Tsunamis thousands of meters high near the impact zone. They raced across the ancient seas at jetliner speeds. Within hours, coastlines across the globe would be hit by walls of water, flooding vast inland regions. Marine life was torn from reefs. Shallow seas were scoured clean. The planet itself seemed to convulse. As the crater expanded, trillions of tons of rock were blasted upward, far beyond the atmosphere. Molten debris rained back down across the globe. Each fragment re-entered the atmosphere at hypersonic speeds, heating the air around it. For hours, the sky glowed red, not from a single fire, but from millions of falling embers. This was not a traditional wildfire. It was a global oven, almost entirely. Daytime became twilight, then near darkness. Photosynthesis slowed, then stopped. Plants began to die, not from fire, but from lack of light. The base of the food chain collapsed. Herbivores starved first. Predators soon followed. This was the beginning of what scientists call an impact winter. The sulfur released by the impact mixed with atmospheric water vapor, forming sulfuric acid. Acid rain fell across the planet for months, possibly years. Freshwater ecosystems collapsed. Soil chemistry changed. Plants already weakened by darkness struggled to survive. In the oceans, the situation was just as severe. Surface waters cooled rapidly. Acidification increased. Plankton populations, critical to marine food webs, declined sharply. Reefs died. Fish populations crashed. Marine reptiles that had survived the initial tsunami now faced starvation. Earth had entered a mass extinction event. Not all dinosaurs died immediately. Some survived the initial firestorms. Others found temporary shelter in burrows, forests, or near water. But survival required food, and food was disappearing everywhere. Large dinosaurs needed enormous amounts of energy. As plants vanished and ecosystems unraveled, their size became a fatal disadvantage. Within months, then years, most non-avian dinosaurs were gone. Only a small lineage, feathered, adaptable, fast-breeding, would survive. We know them today as birds. For thousands of years after the impact, Earth was a quieter place. Forests were sparse. Large animals were rare. The dominant life forms were small, resilient creatures: mammals, insects, amphibians, and birds. Mammals, once living in the shadows of dinosaurs, began to diversify. They filled ecological roles left vacant. The planet was healing slowly. Over millions of years, life returned in new forms. Forests regrew. Oceans stabilized. Mammals grew larger. Some returned to the seas. Others took to the trees or plains. Eventually, primates evolved. Much later, one species learned to walk upright, to shape tools, to look up at the stars. A species that would one day uncover the crater hidden beneath layers of rock and sediment. A species that would learn how close its own existence came to never happening at all. The asteroid that struck 66 million years ago did not target the dinosaurs. It followed the laws of physics, nothing more. Its impact reminds us that life on Earth is resilient, but not invulnerable. The world we know exists because of destruction, survival, and chance. The end of the dinosaurs was not just an ending, it was a beginning.
Look at this anomaly in the sediment.
The impact signature is clearer here.
The curvature here confirms our initial hypothesis.
Exactly. The impact signature is undeniable.